Hi, so I'm going to go over your next programming assignment. This is the second programming assignment using inheritance. And what I have here is a project that has a inheritance hierarchy that we've looked at before. Boat as the superclass. It has two subclasses, and then one of those subclasses is a further subclass. So I'll go over this more, but you're basically going to need to replace these subclasses, this class and the subclasses, the whole class hierarchy, with your own class hierarchy representing some sort of fictional mythical creatures. Totally don't care what it is. Anything from a zombie hierarchy to elves to dwarves to whatever. Okay, it's totally up to you. But you have to have a super class, and then you just need three, right? You don't need to have. Actually, no, I'd like you to do it like this. So you'll need two subclasses of the main class, and then one further down, or something like that, right? I don't care too much. I just want you to have a fairly developed class hierarchy. And each of your creatures should have the ability to basically say what they are, and a few other things which I'll specify in the assignment. Okay? Now what we're going to do, or what I've already done, is I've created in this boating 2D, I've created a two-dimensional world that these boats can move around in. So this is actually the basis of lots of types of games, everything from World of Warcraft to very simple Dungeons and Dragons type game. Any game where there's a map, right, and positions on the map, whether or not you realize it, are represented in an XY coordinate system or a row column coordinate system, so you're going to, in a way that I'll show you in just a minute, your creatures will move around in this little 2D world. Okay? Now, what's this position thing? Well, any creature within the 2D world needs to know where it is, needs to know its position, its XY coordinate. And so you'll notice here in the superclass boat, there is every boat has a position object as part of it so that it can know where it is, right? Its own little GPS. And obviously any class in the class hierarchy, subclass of boat, is going to have that position object as well. Okay? So let's see what this looks like. Well, first, actually, we'll look at it quickly, and then we'll come back and look at boating in more detail. So we're going to go boating here. And here we have three types of boats: power boats, yachts, and kayaks. And they're numbered. There are 20, I think there are 20 of them. And they're moving around this world, right? And each one, when at its turn to move, can move one of 8 positions: directly above it, directly above to the left, above to the right, to its left, to its right, down, directly down, down to left, down to right, right? So those are the 8 squares that surround it in the two-dimensional grid, right? Now, it obviously, if it's on the border here of this little world, it can't move into the positions above it. And same if it's down here, it can't move into positions below it. Right? And if it's here and it's K3's turn to move, it can't move here because there's already a boat there. So how this is handled is actually, it's not terribly complicated, and I'll go over it in just a second, but it's interesting. And so I guess what I was going to say is the case study, which we're going to get to mostly after March break, uses a two-dimensional world. And this program is a good introduction to how to work with a objects in a two-dimensional world. So let's look at boating. So we import random and array lists because we're going to need both of them. We create a two-dimensional array of boat objects called fleet. Make a random object. We define a constant, rows 30, columns 20, and number of boats 20. Okay, here's our constructor. We make a new random object. We make a new, we defined the two-dimensional array up above. Here we actually make one, right? So we've actually allocated memory at this point, and so fleet references that block of memory. They can hold boat objects. Okay, now we're going to place boats in that two-dimensional array, and we're placing 20 boats in there. So first, what we do is we set row equal to a random integer between 0 and I think there were 30 rows, and column equal to a random integer between 0 and 19 columns, right? So that's one of that position within that table, or matrix, or two-dimensional array. And we make a boat type r dot nextInt. Actually, that's just an integer variable, boat type. And must be defined up above. And so then we, that's right, we say boat type equals 0. Then at fleet row column, right, at that position in the board, we make a new powerboat. And we just use the random number here for its constructor, random number generator for its constructor to give different values, right? And you would be like making new orc or something and giving it a power or whatever you want as your fields for each of your creatures. Okay, and then this is interesting right here, right? At this point, that represents a boat object, and I call that boat object set position method and pass in row and column. And what the set position method of the boat class does is it creates a new position object for the boat and puts in that position object the row and column so that the boat knows where it is. Okay? Now, let's look at put fleet in motion. And again, you're not going to need to do anything with these other than to sort of understand them and make them work with your class hierarchy. So we have an array list of boat objects, and I'll explain why we need that in just a second. And we have an array list of position objects. These are the places to move, right? Those 8 places around the boat, which it may not actually be 8 places if the boat is next to the wall or there are other boats immediately adjacent to the boat. It may be less than 8 places, but this will hold the possible places it can move. Okay. A couple of position objects, which will be the new position, which we did select basically from this array list of places to move. We'll select one of them, and that will be the new position. And the old position will be where it was before we've moved it to that new position. Okay. So now what do? We add all the boats in the 2D array to an array list. So we go through and we add if at a given position it's not null, right? Because we only have 20 boats in a much bigger two-dimensional array. So a lot of the positions are not going to have any objects in them, or they're going to be, in other words, they're going to be null, right? So if it's not null, then we take that boat and add it to the array list of boats. Now, why do we do this? It's as simple as this. We want to make sure that at each turn we only move every boat once, right? And what we're doing is we're going through. What we first do is we move references to all the boats into this array list, so that we can then just process through that array list one at a time and move the boats, right? And so, so now they're added to the array list. Now for 100 times, this is just like the number of moves. You can change that. We display the fleet, which is a method further down. And And then this is the version of this for loop called the for each loop. So that this is right for every boat object in the array list boats, one at a time, make a boat equal to first the one at the 0 position and so on. Okay, so first we start making a boat equal to the boat at the 0 position. And then we call this get list of move positions, store it in that array list of places to move. Then we select one of those places to move using the random object, right? And then we say this actually gets a list of position objects. So from each of those we have to extract the row and the column. And this is where the old boat was. We get its position object, and then we extract from it the row and column, right? And because we want to, now that we're moving that boat out of that position, we want to set that position to null. It's empty, so we do that. And then a boat, we tell that boat object to set its new position to that one that we just shows up above, right? So it knows now that it's moved. And now we set fleets of new row, new column equal to a boat, right? So wherever we've decided to move that boat within the two-dimensional array, we now place the boat in that position. Okay, this is just a debugging print line I had there as I was working on this. This is a way to get the computer to pause for a half a second, right? So it pauses for 500 milliseconds, which is millisecond is a thousandths of a second. So 500 is half a second. And so you just need to put all of this, including those two guys at the end, in, and if you want your computer program to pause for a bit, right? So that's, it does this after each readjusting, removing all the boats, because that loop ends the for each loop that moves all the boats. It then pauses for a bit so we can see it, and then goes back and does it again. Okay, let's look at display fleet. This one clears the screen, the UOC. Then we just go typical nested loop structure. If it's null at that particular row column position, we output, if it's not null, sorry, we output the boat type, right? Excuse me, that just prints it in within a 5 space area on the screen. Otherwise, we print out nothing, right? There's nothing there. And again, that nothing is printed within a 5 space area. All right, so that just prints it out. Okay, so this was a little tricky. First, we extract, oh, this is the get list of move positions, right? So we pass in, this is the position of the boat that's passed in. We extract from that the row and column. So now we just need to, we make an array list of positions, objects, and then we just say, okay, this is above, this is directly above. If the, but first it says if it's greater than 0, right? So that if it's not, if row -1 is not greater than 0, this if statement won't be executed because that will immediately short circuit and nothing more will be checked, right? Because we have a, sorry, if that condition, if row -1 isn't greater than or equal to 0, like if it's -1, then because this is an and here, it knows both of these conditions have to be true. So if that one's false, it's out of here, right? It's on to the next thing. Because it's no, why waste time checking the second condition if it's an and, because they both have to be true. Okay, and I'm going to pause here. Yeah, okay, so so we have 3 here, 3 if statements, and this is above to the left, above to the right. Then these 2 are for just the left of the object, this, and then to the right, and then these 3 are below and, oops, that should say below. I just copied these. I forgot to modify these below to to the right. Okay? And that's it. And you just have to make your 3 classes and make it work with this, okay? So we'll just leave it with going, put fleet in motion, and you'll be putting your creatures in motion soon. Okay? And there it goes. It's they're moving around in their little virtual ocean. Okay? If you have questions, let me know. Thanks.